Welcome to the series of Azure ML Toolbox video tutorials. Today I am going to talk about performance measures in Azure ML, that is accuracy, precision, recall, and F1 score. So let's get started. When you build an experiment in Azure ML, you need to score and evaluate it to check the performance and accuracy of the results. To do so, in my experiment, I have created a trained model, and this trained model is passed on to score model, and score model is connected to evaluate model. So for this video tutorial, I'm using the same experiment that I had created in 2-class boosted decision tree video tutorial. So you can watch how I created this model in that video tutorial and then come back here. So in this experiment, we are using Titanic dataset. The score model will give the predictions about the survival of the passengers on Titanic, and then evaluate model will check the accuracy of those results. Let's visualize the output of score model to see the predictions, which are also called as score labels. So survived column tells us the actual values of survival, that is whether a person survived or not. And in scored labels column, it tells us the predicted values for those passengers. 0 means passenger died and 1 means that passenger survived. And next to this, we have scored probabilities column, which is used for predicting the scored labels. If the scored probability is less than 0.5, then scored label is 0. And if it is greater than 0.5, then scored label is 1. As we have seen our scored labels, now we will go ahead and evaluate the performance of these scored labels. For that, right-click on the output port of Evaluate Model and select Visualize. The first thing you will see here is the ROC curve, and we can determine whether our ROC curve is good or not by looking at AUC value. So when you scroll down, you will see all these values, which are AUC, accuracy, true positives, etc. These values are called as confusion matrix. A confusion matrix is a table that is often used to describe the performance of a classification model on a set of test data for which the true values are known. All the measures except AUC can be calculated by using leftmost 4 parameters. So I have created this PowerPoint which will allow you to understand these numbers better. So this is the comparison of actual class versus predicted class. So true positive and true negatives are the observations that are correctly predicted and therefore shown in green color. We want to minimize false positives and false negatives, so they are shown in red color. These terms are a bit confusing. So let's take each term one by one and understand it fully. So true positives. These are correctly predicted positive values, which means that the value of actual class is yes and value of predicted class is also yes, then we get true positive value. In our case, if the value of survived is yes and experiment predicted that this passenger will survive, that means we have got true positives. Next is true negatives. These are correctly predicted negative values, which means that the value of actual class is no and the value of predicted class is also no. In our case, if the passenger is not survived and experiment also tells you that this person won't survive, that means we have got true negatives. After that, we have false positives and false negatives. These values occur when your actual class contradicts with the predicted class. Let's say for false positives, actual class says this passenger did not survive, but predicted class tells you that this passenger will survive. Similarly, for false negative, actual class value indicates that this passenger survived and predicted class tells you that this passenger will die. Therefore, these are incorrect predictions and we want to minimize these. Once we know what is true positive, true negative, false positive, and false negative, we can calculate accuracy, recall, precision, and F1 score. Let's start with accuracy. Accuracy is the most important performance measure, and it is simply a ratio of correctly predicted observations to the total observations. One may think that if we have high accuracy, then our model is the best. Yes, accuracy is a great measure, but only when you have symmetric datasets where values of false positives and false negatives are almost same. Therefore, you have to look at other parameters to evaluate the performance of your model. For our model, we have got 0.803, which means our model is 80% accurate. Now let's talk about precision. Precision is the ratio of correctly predicted positive observations to the total predicted positive observations. The question that this metric answers is of all passengers that labeled as survived, how many actually survived? High precision relates to the low false positive rate. We have got 0.788 precision, which is a pretty good value. Next is recall. Recall is the ratio of correctly predicted positive observations to the all observations in actual class, yes. The question that this metric answers is of all the passengers that truly survived, how many did we label? We have got recall of 0.631. Next is F1 score. The F1 score is the weighted average of precision and recall. Therefore, this score takes both false positives and false negatives into account. Intuitively, it is not as easy to understand as accuracy, but F1 score is usually more useful than accuracy, especially if you have uneven class distribution. It works best if false positives and false negatives have similar cost. If the cost of false positives and false negatives are very different, it is better to look at both precision and recall. In our case, F1 score is 0.701. After that, we have AUC, which is area under the curve. We want to maximize this value. Larger the area under the curve, better the predictions. But if you get perfect 1 in this field, then either there might be something wrong with your model or you don't have enough sample of data. We have got 0.835 in this field, which means our model is good. This measure is used to determine best performing model. Next is threshold. The threshold lets you change the balance of two types of prediction errors, false positives and false negatives. The cost associated with one type of error can be much higher than the cost associated with the other. If that is the case, it makes sense to have error on the side of safety, which means you will accept a much higher number of cheap errors to reduce the number of expensive errors. Therefore, in order to determine optimal value of threshold, you first need to determine the cost of false positives and false negatives. You can move this slider wherever you want. I have kept it in the middle since I don't have same false negatives and false positives. So this is how you can interpret whether your model is good or not by looking at confusion matrix. Thanks for watching.